Today we're going to talk about a single moment way back in 1917 that completely changed how we think about catastrophe. It all went down in a Canadian port city, long before anyone was even thinking about the nuclear age, but it basically wrote the playbook for almost every major industrial disaster that came after it. This is the story of the Halifax Explosion.
So let's just start with a number. 2.9 kilotons. That's the estimated power, in TNT terms, of the explosion that just flattened Halifax. Now, to give you some perspective, this was, hands down, the biggest man-made chemical explosion in history up to that point. Nothing else even came close.
And here's what's so wild about the timing. For almost 30 years, right up until the atomic bomb was used on Hiroshima, Halifax was the benchmark. It was the ultimate example of destruction. When scientists and military planners needed to imagine what it looked like to literally wipe a city off the map, they didn't have to guess. They just looked at the data from Halifax.
So here's how we're going to break this down. We're going to walk through that unbelievable day. We'll look at the collision that started it all, we'll get into the actual physics of the blast, and then we'll see how the rubble of a city was turned into priceless scientific data. And most importantly, we'll understand how this one event totally rewrote the rules for safety and why its warning is frankly more important than ever today.
Okay, let's dive in. The whole story kicks off on the morning of December 6, 1917. The setting is the port of Halifax, Nova Scotia, which was just buzzing with activity because of the war. But the stage was being set for a disaster that wasn't about one single huge mistake, but a whole chain of small, almost understandable failures that just happened to line up perfectly.
Let's talk about one of the ships, the SS Mont Blanc. I mean, to call this thing a cargo ship doesn't do it justice. It was, for all practical purposes, a floating bomb. It was just stuffed with almost 3,000 metric tons of incredibly volatile explosives. Picker acid, TNT, gun cotton, all of it headed for the war in Europe.
And this timeline, this shows just how terrifyingly fast it all fell apart. You've got two ships, the Emo and the munition ship, the Mont Blanc, trying to pass each other in this narrow channel. The collision itself was nothing, really, kind of like a fender bender, but it was enough. Sparks hit barrels of fuel on the deck, and a fire started. And here is the absolute tragic part. For about 15 minutes, the ship is just sitting there burning. People weren't running away, they were curious. Crowds started gathering along the shore, people went to their windows to watch the show, totally oblivious to the ticking time bomb in their harbor. And then, at 9:04 a.m., it went off.
So what does a blast like that actually do? We're about to look at the physics of it, how a simple fire unleashed forces that are, well, they're almost impossible to wrap your head around. This wasn't just an explosion, it was an event that literally reshaped a city in the blink of an eye.
This number, over 1,000 kilopascals, that's the kind of overpressure you get right at the center of the blast. A force like that doesn't just knock buildings down, it vaporizes them. The ship, the pier, everything nearby, just gone. Instantly.
If you need a picture of that kind of power, get this. A piece of the Mont Blanc's anchor, a piece that weighed half a ton, was found more than 3 kilometers away. It wasn't just thrown, it was launched like it came out of a cannon. Just an incredible display of raw, violent force.
And the destruction wasn't just from the air. The blast literally carved out the harbor floor, kicking up a massive tsunami. We're talking about a wave maybe 18 meters high. That's like a 60-foot wall of water that just crashed onto the shore, adding this whole other layer of horror to what was already happening.
And of course, the human cost was just, it's beyond belief. About 2,000 people died, either instantly or very soon after. 9,000 more were injured, a huge chunk of the city's population, homeless in a second. And look at that last point. Hundreds of people were blinded for life. You know why? They were watching the fire from their homes. And when the blast hit, it turned every single window in the city into a spray of supersonic glass shards. As if that wasn't enough, a massive blizzard hit the very next day, burying the ruins and the survivors in snow.
Okay, but here's where the story takes this incredible turn. From all of that chaos and ruin, something new was actually born. The Halifax explosion accidentally became the first great catastrophe to be studied like a science experiment. The ruined city itself became a laboratory. Think about it. The investigators didn't have any of our modern sensors, but they had the aftermath. So they meticulously mapped everything. Where pieces of debris landed, how different buildings collapsed, where people were injured. They worked backwards to create formulas, these things called blast scaling laws, that could predict the destructive power of an explosion. Those same equations were used in World War II to figure out the effects of bombing runs.
It's really remarkable. The very act of responding to the disaster, all the paperwork, the photos, the reports, created this incredible archive.
You had insurance claims that mapped out property damage street by street. You had medical records that showed injury patterns, like how so many people were blinded by glass. They turned a completely chaotic event into a structured set of data they could actually learn from.
And that data led to a whole new way of thinking. See, Halifax didn't just teach us about explosions, it forced a massive shift in how we even think about risk. The question started to change from, okay, who's to blame, to wait, what part of our system failed us?
This is basically the origin story for what we now call normal accident theory. The idea is that this disaster wasn't really caused by one evil person or one moment of gross incompetence. It was caused by a bunch of normal people making what seemed like small, reasonable decisions at the time, all inside a system that had hidden fatal flaws. Flaws in the rules, in communication, in how they handle dangerous things.
You can really track the evolution here. Before Halifax, safety was kind of an art form. It was based on a captain's experience, on personal judgment. After Halifax, it started becoming a science. Safety wasn't just a good idea anymore. It got written down, codified into hard regulations about how to handle dangerous cargo, creating buffer zones. This was the moment safety engineering became a real, formal discipline. But this is the truly scary part. Learning a lesson is one thing, but remembering it, that's something else. This cable shows a heartbreakingly familiar pattern. The same kinds of systemic flaws, mixing dangerous materials right next to cities, letting rules get out of date. It happened again in Texas City in '47, and then again, just unbelievably, in Beirut in 2020. Halifax was the first warning, the origin point for a kind of vulnerability that is very clearly still with us.
And that brings us to the final, and I think most important point. Why are we still talking about an explosion from over a century ago? Because the warning it gave us is more relevant now than ever before.
Long before we ever figured out how to split an atom to make a weapon, we had already figured out how to concentrate enough chemical energy to completely annihilate a city. Halifax was the proof. It showed the world that the power for mass destruction wasn't some exotic new physics. It was already there, hiding in plain sight in our everyday industrial systems.
So that forces you to ask a really uncomfortable question. If the ingredients for this kind of catastrophe are pretty common, then what's the real line between a safe industrial port and a weapon of mass destruction? The lesson from Halifax is that the boundary isn't technological. It's a line that we draw with our choices, with our regulations, our procedures, and what we decide to prioritize.
And that leaves us with this final kind of chilling thought. What Halifax ultimately teaches us is that you don't need a super weapon to have a super disaster. You just need ordinary things, ordinary ships, ordinary chemicals, ordinary ports, to all align in exactly the wrong configuration. The potential for another Halifax isn't hidden away in some top-secret silo. It's potentially latent within the very infrastructure of the world we've built all around us.